All right, so this video is going to serve as a pre-lab to the molar mass by freezing point depression method that we're going to do tomorrow. So you need to make sure you watch the video. There will be a short quiz before the lab starts tomorrow, so make sure you can answer some key questions. Basically, what we're going to do is we're going to figure out by freezing point depression, because remember when we studied solutions in chapter 12, that if you put solutes in something, if you look, the key thing is number of particles. The more particles you have, it affected. You had a higher boiling point. These are colligative properties, a lower freezing point, and a lower vapor pressure. That was the idea. Those are the three colligative properties. We talked about osmotic pressure too, actually. So the greater the number of particles, the higher the boiling point, the lower the freezing point. Those are all things we learned in chapter 12. One of the things we can actually do in chemistry is we can actually find the molar mass of a solute, the particles that are dissolved, using this modified equation. What you do is you take the KFP for freezing point, the grams of solute, you're going to measure this out on a balance. So tomorrow you're going to measure the grams of solute on the balance. Kilograms of solvent, that's going to be BHT that we're going to use for this one. You're going to actually measure that on a balance also. So you're going to mass this. You find the mass in grams and then convert to kilograms. This you'll find the mass in grams, and it's already in grams. What you need is you need the delta T. The KF for BHT I will give you. And so the key part of the lab that you're trying to do tomorrow is you're trying to figure out what the temperature and freezing point, the difference is between the pure substance, so a pure substance, and if you increase the number of particles, the freezing point should go down. So that's really what we're going to do in the lab, is we're going to boil the pure substance. Actually, we're going to freeze the pure substance. It freezes at a temperature of, I believe, around 68 degrees Celsius. So we're going to freeze it normal. We're going to put something in there, and according to what we learned, the freezing point should drop. Well, how are we going to do that? Well, your setup's going to look like this tomorrow. You're going to use a computer hooked up to a temperature probe. You see the temperature probe right here in the photo, little Mac laptop. So we're going to grab a Mac laptop. We're going to use Data Studio. The setup's going to involve a temperature probe. You're going to need a boiling water bath. So you're going to have when you walk into class, it should already be going. You should have a hot plate, boiling water bath, so the water will be boiling. And then we have a test tube set up with a clamp, and then the temperature probe that's wired to the computer. Key thing is, notice how I wrap the wire around the ring stand, because if the wire touches the hot plate, it will burn through the wire. So one of the key things in your setup is to make sure that you wrap the wire, have it connected to the computer, but nowhere near the hot plate. The surface of the hot plate would be hot, hence the term hot plate. Therefore, it would actually burn the computer wire. So you're going to set this up. It's actually a closer view of it's going to look like this. So if you notice, you see the wire wrapped around there, drops down on the side and hooked up to the computer over here. Here's an artist rendition of a computer. I know it's fancy. There you go. And then what you're going to do is you're basically going to put your solute, your BHT is going to go in the bottom of the test tube right here. We're going to submerge it in a hot water bath, which will liquefy it. Once it completely liquefies, you're going to pull it back out above the water bath and let it cool. During that time, you're going to actually use the thermometer you see in the picture here to stir it. So you're going to stir the solution not in the water bath. The only time we use a water bath is to liquefy something so we can see when it cools. The cooling point for it normally is around 68 degrees Celsius. So you'll continue to stir it. When you go to set it up on a laptop, all you're going to do is hook it up to the same thing that we did Hess's Law last time. You're just going to open it up, click Create Experiment on the computer, and then you're going to have time on the bottom, temperature, and then you're going to click on this once you start to, once you liquefy it, when you start to cool it. So if it liquefies, you pull the test tube out of the water, that's when you click Start. So you click Start on the computer once you pull the test tube above the hot water bath. And then it's going to time and it'll track the data. This is what you're trying to do. The whole point is to find delta T. So you're trying to find delta T. In order to do that, we'll have one cooling. You'll see cooling is a linear function, just like we saw in Hess's Law. So you have one area that will cool, hopefully not super cool, then level off. When it levels off, that's when it goes from being a liquid, this is a liquid here, towards being a solid, because it's a cooling curve. So this is the phase change right here. This area I'll highlight in yellow represents a phase change. If you trace it back over here on the graph, that would represent, this will represent its normal freezing point. So you'll get one of those. So you can do the experiment. You're going to click start when you pull it out of the water. Computer's going to track it. You see it in red, 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 level off. Once it levels off for a little while, plateaus, flattens out, whatever you want to call it, then you're going to hit stop. Then you're going to go and measure out 1 gram of unknown and dump it in there and liquefy it again by dumping it in the hot water bath. Then what's going to happen is you're going to pull it out again and you're going to let it cool. This time you're going to see a second graph, and you want both the graphs on the computer at the same time. So you're going to click stop after the first one, add the 1 gram, liquefy it again, and then you're going to put it back in the hot water bath, liquefy it, and then click start again. So you'll end up with 2 graphs, 2 lines on the same graph basically. The second line will be with the solution, with the solute in there. We know that the freezing point should be lower. So it's going to be lower than 68. It'll flatten out. It'll probably look a little flatter than this. The distance between the 2 flat areas represents the delta T, and that's the whole point of doing this lab. We can measure out mass of the solute on a balance. We can measure out mass of the solvent on the balance. I can tell you what the KF for BHT is. What you need to find out is the delta TF. So what we're going to do is we're going to cool it twice. We're going to freeze it twice. The difference between the 2 lines is going to represent our delta T for the freezing point change. Change in the freezing point. So then we can go back to this equation right here. Go back to this equation. We have the yellow value. We can figure out or calculate out what the molar mass of the unknown is. This is a common general chemistry lab that you're expected to do in college. So then these are the instructions you're going to print out. The first thing is you just have to measure 8 grams of BHT, and you don't actually have to weigh the test tube. You can weigh it in a weighing boat. We have weighing boats. So your step number 1 when you start is you're going to weigh the BHT 8 grams. You're going to record the weight in your data table. Then you're going to put the clamp and the test tube in the water and bath and liquefy it. Then insert the thermometer after you remove it. So you're going to heat the water bath to about 90. It should take about 3 or 4 minutes. It'll liquefy. And then you record the temperature of the BHT for every 20 seconds, but the computer's going to do it for you every half second. And then you're going to keep in mind you have to continuously stir with the thermometer, and then over time you'll end up with a graph where it flattens out. You record the values until you can go like a minute with that not really changing any temperature, a flat area, and then you hit stop. And then what you're going to do, the next step, is you're going to repeat the exact same experiment. You're going to repeat the exact same procedure. You're going to use BHT. You don't even need fresh BHT. You can just liquefy the same one with 1 gram of the unknown. So you go to the balance. You measure 1 gram of the unknown. You're going to mass that out in a weigh boat, dump that into the same test tube, liquefy it again. Once it's completely liquefied, you pull it out of the water bath, as you see in the photo here. It will be pulled out of the hot water bath, and then you let it cool. That's when you click start on the computer. So some key things you need to remember for points in case I ask. Basic one is, how much BHT do you need? You need 8 grams. You're going to weigh it out on a weigh boat and dump it in the test tube. When do you click on the computer? You click start on the computer when it has been liquefied and you remove it from bath. So once you remove the test tube from the bath, that's when you click start on the computer. From bath, click start. Another thing you need to know is how much unknown. You're going to weigh out 1 gram of the unknown. You're going to add it to the existing test tube that you have, re-liquefy it, and then click start again. Please do not start another graph. You need to see both sets of lines on the graph. So the way you do that is by clicking start for the first one. It cools. Click stop. Then liquefy it again with the unknown. Once you pull it out of the bath, only when it's out of the bath do you track temperature. You never track the temperature when it's, because you only want to track the temperature when it's cooling. And you'll have a nice successful lab. It's easy to do within a class period. I'll have the hot water baths ready to go for you. The only other thing is to remove the thermometer at the end of the whole lab period. The only way you can get BHT off the thermometer is at the end of the lab, you put the test tube back in, let it liquefy one last time, and wipe the thermometer with a paper towel. So for cleanup procedure, make sure that you liquefy it one last time using the hot water bath in your setup, and then clean it with a paper towel while it's liquefied. Otherwise, there will be stuff all over the thermometer. Okay? Have a nice evening. Get ready for the lab. Make sure you wear closed-toed shoes. Make sure that you have your lab book ready to go. You should have the purpose. The procedure I just discussed, you can basically write it step by step. It's in paragraph form. Where are we here? It's in paragraph form here, but you should break it out into step form. Just write all that. It's not that much. And just remember some key points because I am going to ask you some key points. Have a nice evening.